In this video, we're going to go over some of the calculations that are the practical side of the cost approach. And what I'm going to do is look through the different ways that you can use the cost approach equation by changing it around basically. And so we're first of all going to look at how you can use it to calculate depreciation from market evidence. Then we're going to look at the way that you can use it to work out land values. And finally we're going to use it in the more conventional way, if you like, to work out the property value. Let's have a look now.
We're going to begin by looking at the way that we can use the cost approach to calculate the depreciation. Now the reason we do this is because although there are a number of ways of calculating the depreciation, working it out from your market evidence is about the most direct and appropriate for valuation purposes. And really what we're going to be doing here is virtually using a cost approach more or less in reverse. We're going to assume that we have the sale price from a comparable property, and we also know the land value. We might know that from comparable land sales where the land has been sold without any improvements. And from that and our numbers from Rawlinson's or wherever else we get our construction costs from, we're going to work out the depreciation on a particular property. Okay, so here we have a sale price of $500, a land value of $220. By the way, you'll notice that I'm adopting some conventions in these exercises. The first one is that data is all shown in blue font color. The reason for that is that it makes it obvious where the equations are. It's also the same color convention that is used by the estate master company, and some of you going into development will probably find yourself using that particular package, and so I adopt the same conventions as estate master for our input colors. The other thing about these exercises is that you'll notice there are a number of yellow highlights. I've actually got a yellow border around this one, which is not important, but the important thing is these yellow highlights. These are self-correcting exercises. What that means is that as you insert the correct number, or usually the correct equation, the yellow highlights will disappear. And that way, as you get the correct equations built into your model, you can actually see it correcting itself by getting rid of those yellow highlights. And we'll be doing a lot of these self-correcting exercises as you move through your valuation studies. Let's look at the first one now. What we want to do is strip away the land value from the price, and we also want to strip away what we call the ancillaries, those minor improvements which we aren't really that important, but we need to take into account one way or another. Here we're saying we've got a driveway, some fencing and some landscaping. We've done estimates of those. That comes from your experience, maybe from Rawlinson's, maybe from speaking to contractors and builders in your region. These values all change very much by region, and so it's important to learn as much and keep your eye out for getting a feel for the construction costs of different things. Okay, the other issue, if you like, or aspect about these exercises is that they have protection switched on. That's so that we don't give too many of the secrets of how the self-correcting exercise mechanism works, but it does mean that there are some functions we can't use. For instance, if we come up into the top right hand corner here, there's a nice big sigma button here, extraordinarily important function in Excel, and it saves a lot of trouble, but when protection is on you can't use it, and so unfortunately we'll just have to bear with that. Okay, what are we going to do here? First of all, we want to add up these ancillary items. Normally I would use sigma. I'm going to do the equivalent though. I'm going to write in sum, open brackets, then I'm going to select the array of cells which has the numbers in, close brackets. That's basically what the sigma button does, all shorthand for us. That will give us the sum of those things. And so we have 17,100. You can check that on a financial calculator or any calculator for these calculations, and you'll notice the yellow highlight is gone. Now I want to find out what is left after our sale price after we take off the land value and the ancillaries. So I'm going to write an equation, and for those of you who are unfamiliar with Excel, we're going to be using Excel extensively through our property studies, so it's a good idea for you to get up to speed with Excel yourself. The way Excel equations are written, we start with an equation, an equal sign, and then we simply write our equation pretty much the way you'd write it on paper. A couple of little exceptions that we'll get to as we go along. So this is, I'm going to start off with the sale price, which is in cell G7, subtract from it the land value, which is in cell G8. I'm going to subtract from that the sum of the ancillaries, and I simply hit enter. What that means is that out of the $500,000 that the property is worth, there's $262,900 which is accounted for by the main building, because we've taken off the land and all these other bits and pieces. Okay, next step, we're going to look at the building. Now there are some conventions, if you like, these are simplification methods, if you like, that valuers use. You don't have to do it this way, but a lot of valuers do. We can go to direct estimates, and the simplification we're going to use is that we're going to consider the cheaper parts of the building, like the veranda and the garage, that may not have the same quality of finish, may not have the same linings or the floor coverings or whatever. They don't have any allowance for bathrooms and kitchens. I'm going to say that we can discount their costs of construction as a percentage of the cost of construction of the main part of the building. And so in this case we're going to say that a veranda costs about 70% of the main building to build, and a garage costs about 75%. Now the data we've got from going out and doing our field inspection, measuring things up, is we've got a number of areas here, 161 metres for the main part of the house, 33 for the veranda, 38 for the garage. Now we're going to work out the equivalent areas. Well, the first one's pretty easy because it's 161 times 100%, in other words times 1. We don't even have to do an equation here, but I'm actually going to do this equation because I'm going to show you a few what I call laziness functions in Excel, ways of saving time and effort. Here I've written one equation. The way it's written though, notice if I grab it by pointing and clicking on the lower right hand corner here where the cursor changed shape, I can just pull that down, and that actually causes this equation to be reproduced in each row below and also adjusted for the respective data. Here this equation is taking cells C19 and D19 to multiply together to give the equivalent area. When I come down to the garage, I notice this equation has been adjusted to give me the equation worked out on the garage's data, which is its area and allowance. That's a nice little laziness function. It saves a bit of time. Now I can add up all of these. Again, if you didn't have a protected worksheet, you'd be able to hit the sigma button. Here I'm going to go or type sum. Now I'm going to select the list of values that I want to add up and put them down. There are other ways of doing this. I could simply use the addition function quite simply. But there we have it. It's a total equivalent area of 212, which is going to be built at the whatever cost of construction. Now, when I look at the value of the property which is accounted for by the building, what I can do is work out its equivalent value per square metre. And so I can simply divide the 262,900 by the number of square metres which are in the equivalent building, and that gives me an equivalent cost of construction, or value of construction if you like, of $1,236.59 per square metre. And so if I multiply that 1236 by 2112, I'll get that number. You'll notice my yellow highlights are disappearing. Okay, I've looked up in my construction cost handbook, either Rawlinson's or Cordell's or some other listing of construction costs, and it tells me that to build a comparable building in Rockhampton, which is where I'm basing this from, it would cost me $1,300 per square metre. So what I can do is very simply work out what fraction of new value is the building. So I do that by simply dividing the value per square metre that I've worked out by the construction cost new, and that says that the building, through my analysis, is 95% of the value of a new building. From that, I can work out how much the building has lost in value. I can simply subtract 0.95 or 95% from 1, and that will tell me that I've got depreciation of 5%. Too easy. Let's move now to how we can use this to calculate our property value. You notice I'm going to skip over the land value exercise, and the reason I'm going to do that is that I only intend to actually demonstrate two of these models. I'm going to get you to do the third. I'll just have a quick look in here. You'll see it has the same kind of form, if you like, but the parts are ordered in a different way. I'd like you to think about what you're going to be doing, maybe go back to the study guide, work out which equation we're actually evaluating here, and you'll be able to work this out, get rid of the yellow highlights. You'll notice I've got a bottom line here which is to adopt a particular value. I recommend here that you round to about the nearest $1,000, and you can do that using built-in functions in Excel, but I'm not going to demonstrate this one. I'm going to just go straight to the property value one. Again, looks pretty similar. There's a different edging around it, and the yellow highlights in a slightly different place. But in this exercise, we're going to assume that we know the depreciation and we know the land value, which were the results of the previous two. What situation do we have for that? Well, this is where I'm actually using it to value a property. In the previous two exercises, I was using actual sales, comparable sales, to analyze, to compute important values like the land value or the depreciation. Here I'm assuming that one way or another I've worked those things out, or I've found them from the market, or whatever I've done, and I'm going to be using now the cost approach to value my subject property. Let's go into this. Now you'll notice, by the way, that we're using the same data for all of these exercises. That's just to get it started, basically. Okay, now what have we got? We've got a similar building. You'll notice it's very, very similar. And we've also got the allowances. Now we're going to work out what the costs per square metre are. Now notice it's almost an opposite calculation to the last one we did. What we're going to have here is the building cost per square metre. Now we're going to multiply that by the 70%. So what we're going to say is that if it costs us $1,300 per square metre to build the main part of the building, how much is it going to cost per square metre to build the veranda? And so that's very easy. It's equal to the full cost multiplied by 70%. Now you'll notice I snuck in a couple of dollar signs into the first cell address here. Those dollar signs come in by pressing the F4 key if you're using a Windows computer, and you'll have to find it yourself if you're using a Mac. But the advantage of those dollar signs is that it means that now when I fill the equation down, while I want to change where I'm getting my allowance from, it's always going to come back here to this one spot. It fixes it, makes it absolute. And so E7 is now an absolute cell address. Put that in. There goes the yellow highlight. Pull down, and it's given me the 975. Again, the yellow highlight's going away, telling me that I'm doing the correct mathematics. Now I'm going to work out actually how much these different parts cost to build. I'm going to do that by multiplying the floor area by the cost to construct. And I could write these equations over and over again, but I can also fill them down. That simply saves me a little bit of effort. I'll do this longhand, so I'll simply do it with addition symbols. We don't need that last addition symbol. If you're not using a protected worksheet, you can use the sigma button. Saves a bit of time. Okay, now we're going to take off 5% depreciation. We do that by multiplying the full cost by 5%, and then we're going to subtract from the 276, which is the new cost. We're going to subtract the depreciation amount. So that means that now we have $262,561 worth of building. We need to work out our ancillary costs. Again, I'll do it with the sum SUM, open brackets, pull that stuff in. I guess that might be a little tiny bit faster. Now I'm going to add the ancillaries to the main building. That gives me 279. Now I'm going to add the land value, and so it's 279 plus 220, da-de-da. And now I'm going to adopt, well, that's looking very, very much like $500,000. What I'm going to do is use an Excel function because I'm extremely lazy. I'm going to go round, lovely little function that, and that's going to round the number which is in the cell that I select there to the number of decimal places that I select. Now that round function normally works to give me so many decimal places, numbers after the decimal point. I'm going to want to actually round it to the nearest $1,000, and so I'm going to do -3. So that's -3 decimal places. If you think that through, that really brings the rounding function into the whole numbers and into the thousands, in fact, rather than into the decimals. Either way, that causes the machine to round to 500,000. You can do that by hand if you don't want to use the round function. But a lot of these things, it's a good idea for you to experiment and learn how these different functions work, because the more Excel functions you learn, the faster you'll get at it and the easier these things are to build. Okay, last thing to notice, I've used one example for each one of these demonstrations. Now that we have the model built, we don't have to stay with these particular values. And in fact, now that you've built this model, you may want to keep it to use in practice or as a basis for other work you may want to do. All of the blue numbers can change, and that means that you can use this model in practice. So for instance, we can change the veranda from 33 to 40 square meters, and the whole model works out. Now the value of the house or the property is 506,000 and so on. And likewise, if the house is only 120 square meters, it sort of brings it out accordingly. The nice thing about writing these models as equations is it gives you this power and this flexibility into the future. Now what I'd like you to do is go back to the land value model and go through and get rid of those yellow highlights, and the result of all of that should give you a very useful set of models and also a little bit of experience, which should help you to understand the way that the practicalities of the cost approach works.